Welcome dear student. Today we will continue a second part of the lesson, that is current, electricity and magnetism. So yesterday or in our previous session we have covered the topic like electric cell, dry cells, lead acid cell, nickel cadmium cell. Now let's move further. Students, today we will going to see about electric circle. Students, when a cell holder, an electric bulb and a plug key are connected by connecting wires, you can see in the figure. Connecting wire, it is connected with the battery, switch, light bulb and a wire which carries electrons. And a dry cell is fitted in the holder. Dry cell, a battery which has two terminals, positive terminal as well as negative terminal. Then the bulb lights up by closing the plug key. Now students, when we close the plug key, that is a switch. In next figure you can see a switch. Okay, switch, battery, a wire and a bulb, light bulb. Now if we close a plug key or switch, what happened? The bulb will lights up. This means that a current flows through the circuit and bulb light up. That means if we switch off the plug key or switch, what happens? The current or the electrons will flow from a wire which produces the electricity in the wire and which cause the bulb to light up. On the removal of the cell, the electric current flowing through the circuit stops. And if we remove the cell or a battery, the electric current flowing through the circuit will stop, as indicated by the bulb which ceases to glow. This type of connection of electrical component is called as an electric circuit. So you can see in a diagram showing a simple electric circle containing switch or plug key, battery or a cell, wire and a bulb, light bulb. Now students, here you can see a symbol of a cell, positive terminal and a negative terminal. Now students, here on the right hand side you can see a picture of a cell holder. An electric circuit. Now students, here you can see a picture in which it is showing that if we switch on the plug key or a switch which is connected with a battery and a bulb, what happened? If we switch on a switch or a plug key, what happened? Electrons will start flowing in a wire due to the cell. And what is the cell doing here? Cell is converting its chemical energy into an electrical energy. So if the switch will on, what happened? Due to the producing of electricity, the bulb will lights up. But if we switch off the plug key or the switch, what happened? The flow of electrons in the wire will stop and the bulb will not light up. You can also see a simple circuit showing below in the figure. Now here students, here some of the symbols are present. Some of the symbols are present which shows in the picture of the electrical circuit. So these symbols are used in a electrical circuit. Now first is a symbol of cell. Second, symbol of bulb. You can see the switch on symbol and switch off symbol. And you can see a battery. Now students, what is battery? When many cells are connected together, it is called as a battery. Now these are the cell only, but many cells are connected together, so it's called a battery. An electrical circuit is also used in the home supply. However, the electricity supply is made from outside instead of the electric cells. We will learn about this later. Research. Lithium ion cells are used in modern equipments, for example, smartphones, laptops, etc. These cells can be recharged and more electrical energy can be stored in these cells as compared to that in nickel cadmium cell. Now in nickel cadmium cell we have seen that it produces only 2 volt potential difference, but this nickel cadmium lithium ion cell will produce more potential difference than that of the nickel cadmium cells. Now we are going to learn about connecting cells. Now students, you must have seen more than one electric cells connected in an electric circuit as shown in the figure. Now in the transistor radio, 2 to 3 dry cells are seen to be connected in a series. Now students, in a series, that means one after the other, in a series, that means in one line. The purpose of doing this is to obtain more potential difference than that of a single cell. Now student, single cell will produce very less amount of potential difference, but this type of a cell, if for example we can see that if single cell will produce 1 volt of potential difference, then here 4 cells are connected, you can see. So 4 cells will produce the potential difference of 4 volt. That means the potential difference produced by these connecting cells is more than that of the one single cell. Therefore, it is possible to obtain higher current if the cells are connected as seen in the figure. Okay. If the cells are connected as seen in the diagram, the connection of cells is known as a battery. Now students, one cell means single cell, okay, but if the many cells are connected in a line, it is called as a battery, and this I have already told you in the figure showing a symbol of a battery. In this series connection, now students, in the second diagram you can see this how the cells are connected in series, that means in a one line. Okay, in this series connection, the positive terminal of one cell C is connected to the negative terminal of the second cell, and the positive terminal of the second cell is connected to the negative terminal of the third one, and so on. So you can see in the second diagram that positive positive negative terminal, okay, E1, we can say that E1, that is negative terminal of the first cell, is connected with the positive terminal of the second cell, and the negative terminal of the second cell can be connected with the positive terminal of the third cell. Therefore, if each cell has a potential difference of 1 volt, that means if a potential difference of a single cell is a 1 volt, then the potential difference of 3 cell will be, obviously it is 3 volts, students. Now students, in the first diagram you can see how the cells are arranged parallel to each other. Okay, so these are the two types of batteries. First, which is in which the cells are connected in a series, and second, the cells are connected in the parallel arrangement. Okay, so in parallel arrangement you can see upper part is a positive terminal is upper side and the negative terminal on the downward side, but in the series, negative terminal is connected to the positive terminal of next cell, and that negative terminal of the second cell connected to the positive terminal of the third cell. Use your brain power. You must have seen the car battery available in the market. It is called a battery, not a cell. Why it is so? Students, a cell is a single unit that converts a chemical energy into an electrical energy. So a battery is a collection of cells and are connected in series. So in a car, a single cell doesn't have enough potential to the car. Therefore, a battery is used in a car instead of a cell to produce more potential difference or more amount of electricity or current. Now students, we will see about the second part of the chapter, that is magnetism. Let's see some let's see about the magnetism. So students, magnetism is a force exerted by the magnets when they attract or repel each other. Magnetism is caused by the motion of electric charges. Now electric charges means magnetism is caused by the motion of electrons or flow of electrons. So it's all about the magnet and electricity or electric charges. Now we will see. Now we will going to learn about magnetic effects of a electric current. Now students, to understand this, we will see. We will perform one activity. Now let's talk about the activity. Now in the activity 1, take the inside tray of an used up matchbox you can see in the picture. Place a small magnetic needle inside the tray. Now students, on the left hand side you can see a picture of a magnetic compass. This is called as a magnetic compass, and the red and blue needle, okay, this red needle indicating the some points, this is called as a magnetic needle. Now take a long connecting wire and wind it around the tray. Complete the electric circuit by connecting in it this wire, electric cell, plug key and a bulb. You can see in the diagram also that a cell is connected to the bulb and a matchbox tray containing a magnetic compass with needle. Mark the position of the magnetic needle. Take a bar magnet near to the magnetic needle. What do you observe? What do you observe? Students, keep looking at the needle and close the plug key. The bulb will light up and you will realize that the current has started flowing. Now students, if here we have to take a long connecting wire, okay, with a magnetic needle in a tray, battery and a bulb. Now if we if we switch off the plug key, what happened? The current will start moving from that wire or a conductor. So due to the flow of electron in the wire, the bulb will light up. But here what happens, the difference here is magnetic field. Magnetic field will be produced. Why magnetic field will produce? Because here we have kept a magnetic needle, and if the magnetic electric charge will electric charge or a flow of electron will cause the needle to move, and due to this magnetic field around the wire will be produces, and due to this electricity produce, and due to this process the bulb will light up. Now students, here you can see the semicircular shape which is the magnetic field lines, which is produced due to the magnet and magnetic needles. So the bulb will light up and you will realize that the current has started flowing. Does the magnetic needle change its position? Now what we will do? Now we will open the plug key. Does the magnetic needle come back to the original position? Now students, from this experiment we can see that a magnetic needle is indeed a magnet, and we have seen that the magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. That means when a bar magnet, which we can see in the second picture, that if the bar magnet taken towards the magnetic needle, what happen? Change the direction of the magnetic needle will takes place. And also we will observe, and also you have observed that the magnetic needle changes its direction when a current starts flowing in the circuit. This means that magnetic field is created when an electric current flows in a wire. Now Hans Christian Ørsted made this observation first. When an electric current passes through a wire, a magnetic field is produced around the wire. Students, in the diagram you can see a wire which carries a current, that means a wire which carries a flow of an electron inside it, and on that we have a magnet or magnetic needle. So due to this flow of electron, magnetic field will produces around the wire. Now we will perform an electromagnet. Now first of all, students, what is an electromagnet? In simple words, electromagnet is a type of a magnet in which the magnetic field is produced by an electric current. Now students, to perform this activity, we have to take an iron nail, a long coil of a insulated wire, a battery and a switch, and of course some pins to perform this activity. Now students, what we will do, we will connect the two ends of the wire in a circuit as shown in the diagram. You can see a red wire which is connected two ends of the wire in a circuit as shown in the diagram, and also we have to connect an electric cell. You can see a battery cell, okay, an electric cell and a plug key or a switch in the circuit. Now keep 2 to 4 iron pins or nails near the screw. Now start the current in a circuit by plugging the key. It will be noticed that the pins have stuck to the tip of the screw. Now if we will on the switch, then what happened? The pins will stick up to the iron nail, and when the nails continue to stick when the plug key is open. Now let's see. Now when the electric current flows in the wire, magnetism or magnetic field is produced in the coil around the screw, and because of that the screw also attains magnetism. As soon as we will stop the current, you can see in the next picture, if we will stop the current, this magnetism vanishes. That means this magnetism will disappear or it will be removed. The system of coil and the screw is called as an electromagnet. Now student, first of all, in this activity what we have to do, we have to connect the wire with iron nail, battery, switch. Okay, now what will happen, if we will on the switch on the plug key or switch, the pins which we have kept near the screw, it will start attracting towards it. And why this is so? Because an iron nail start producing the magnetism will produce within the circuit or within the iron nail. That's why the pins will start attracting towards it. But if we will stop the switch or plug key, what happened? The pins will be fallen off from the screw. Why? Because the magnetic field which is produced due to the cell has been stopped. That's why pins have fallen from the screw. Here also I have put one picture for you students, in which you can observe a magnetic field. Now what is the electromagnet? When an electric current is passed through a coil of wire wrapped around a metal core, a very strong magnetic field is produced. This is called an electromagnet. Now last part of the chapter is electrical. Now students, you can see a red one electric bell. Many of you must have seen the simple electric doorbell. If we will open such a bell which is out of the order, is a bell with its outer cover removed. We see that first diagram is an electromagnet inside. Let us understand the working of the bell. Now a copper wire is wound around an iron piece. You can see an iron piece which is wound with the copper wire, and this coil acts as an electromagnet. An iron strip along with a striker is fitted near to the electromagnet. A contact screw is in touch with the strip. The electric circuit is connected as shown in the figure. You can see an electric circuit connected with a wire, switch and iron magnets. The current flows in the circuit when a screw is in contact with the strip, and hence the coil becomes a magnet and attracts the iron strip towards it. Therefore, the striker hits the gong and the sound is created. However, at the same time, the contact screw loses the contact with the strip and the current in the circuit will stops. In this situation, the electromagnet loses its magnetism and the iron strips moves back and come in contact with the contact screw. The electric current is then immediately restored and again the striker hits a gong. By the above process, this action repeats itself and the bell rings. So students, here you can see if the striker will strike the bell, the current or the electricity will generated inside the circuit, due to which the bell will ring. And if the striker will stop hitting the bell, the circuit will stops and it will come to its original position, and this process will going on as the bell will ring. Thank you students.